So far in this unit, we've talked a ton about polynomials, but what we've done with polynomials is generally factored them. Well, the reality is that even though you have numbers that are factorable, you sometimes have numbers where you could divide them and get a decimal answer or a fractional answer, and the same is true with polynomials. So in addition to being able to factor polynomials, it's important that you understand how to do division, just division, where sometimes you're going to have a remainder and sometimes you won't. So let's just do some examples here. So first example is a little bit of a side trail because normally what we're going to be talking about in this lesson is dividing a polynomial by another polynomial, and here we only have a monomial in the denominator. So your procedure here is you can just look at each piece. So notice we're dividing the entire binomial on the numerator by 2z squared. So we can rewrite this as 10z to the fourth over 2z squared minus 6z to the third over 2z squared. And then just apply laws of exponents to both of those to simplify. So 10 divided by 2 is 5, like it's always been. And then z to the fourth over z squared. Remember, we subtract exponents of like bases, so we end up with 5z squared minus 6 over 2 is 3. And z cubed over z squared is just z to the first. And there is our final answer for the division problem. Now, some of the other ones are a little messier than that, but you can still simplify just like we did on that first question. So we're going to go ahead and break this one up. So we'll say x squared over 2x plus 6 over 2x, and then we can simplify each part. So x squared over 2x, we end up with just an x over 2, and then plus, and then 6 over 2 will simplify down to 3 or 3 over 1, so we have 3 over x, and there's our final quotient. All right, now before we go on to the next topic, I'm going to do a major blast from the past. So something you haven't seen since you were probably in elementary or early middle school. We're going to actually do a long division question. But it's really important to understand the concept of just numerical long division before we get into polynomial long division. So let's go ahead and do this one. So I'm going to go ahead and put 2544 inside our division symbol, and we'll divide it by 16. Now remember the procedure for this. We're going to ask ourselves, how many times does 16 go into 25? And we say it goes in once. Then we're going to multiply 1 by 16 and write down our product, and then subtract. So then we do 25 minus 16, so we're going to have to borrow, and 15 minus 6 is 9. Then we bring down the next digit. So now we ask ourselves, how many times does 16 go into 94? It goes 5 times, so then 5 times 6 is 30. We can carry our 3. 5 times 1 plus 3 is 8, and again, we subtract. We get 14, and we can bring down our final 4. Now, how many times does 16 go into 144? It goes in 9. Now, if we multiply 9 times 16, so 9 times 6 is 54. And then 9 times 1 plus 5 is 14. And notice here, we have a remainder of 0. So not only is that a good review of basic numerical long division, but it also helps you understand a concept about factors. So here's the reality. Because 2,544 divided by 16 had no remainder, we could say that 16 is a factor. So 16 is a factor of 2,544. So keep that in mind when you have a remainder. You've just found a legitimate factor for that number, or in our case, for that particular polynomial. All right, so let's apply numerical long division and that process to a polynomial. So remember, our top polynomial goes inside the box, and the bottom goes outside. So same as the other question. Now we're going to ask ourselves, how many times does x go into x squared? Right? I kind of think of it as x times what gives you x squared. Well, hopefully you're saying it's x times x. I try to keep my numbers lined up, so my x to the first terms I try to keep in the same column. And if I had an x squared term, I try to keep it in the same column. And then I've got a constant column. So I try to just keep myself organized so I don't get lost in the process. All right, so now, just like with numerical long division, we're going to multiply x times the quantity x plus 2. So we're going to do x times x to get x squared, and x times 2 to get 2x. Now remember, the next step in the process is to subtract. So x squared minus x squared is 0, and then negative 3x minus 2x is negative 5x. And then remember, we drop the next term. So we'll have negative 5x minus 10, and again, we ask ourselves, how many times does x go into negative 5x? Or x times what gives you negative 5x? And hopefully you're saying minus 5. I want you to notice I'm still lined up. I've got constants over constants. Now I'm going to multiply negative 5 times the quantity x plus 2, and I'm going to end up getting negative 5x minus 10, and our remainder now is a 0. What does this tell us? This tells us that x minus 5 is a factor of x squared minus 3x minus 10. And think about that. Let's just do that. If we factored this, we would be looking for the factors of negative 10 that add to negative 3, and those factors would end up being an x minus 5 and an x plus 2. So notice what we have here is x plus 2 is being divided out. What you have left is an x minus 5. So that one was nice because we didn't have a remainder. Unfortunately, they're not always going to be quite that nice, and let's do one of those examples now. So here, we've got a long, messy polynomial division question. I want you to notice something before we start. This is really important to keep yourself from getting confused. I want you to notice that your first term is an x to the 4th, and then you have an x to the 3rd, and then you skip x squared and go to x to the 1st, and then essentially x to the 0 right there. You need to fill in the gap there. So let's talk about what that looks like. We're going to go ahead and write down that first polynomial inside our division box. But what we're going to do is we're going to start off writing down what we have, but then we're going to add a 0x squared. It's just kind of a placeholder to keep your work organized. So now I'll continue, and I have a complete polynomial where I don't have any terms missing. So it goes 4, 3, 2, 1, 0, and now I can do my long division a little bit easier. So on the outside, I'm going to have x squared plus x plus 2. All right, and let's go through the process. So first question, how many times does x squared go into x to the 4th? Or in other words, x squared times what gives you x to the 4th? Hopefully you're saying x squared, and I'm going to go ahead and put my x squared in the x squared column. This is also why we want to keep that 0x squared there. So now we're going to multiply the trinomial on the outside by x squared. So we'll end up with x to the 4th, and we'll have x squared times x, so plus x cubed, and then x squared times 2, so plus 2x squared. Next, we subtract. This goes away. We end up with a negative 6x cubed minus x cubed, so we end up with a negative 7x cubed. Then 0 minus 2x squared is a negative 2x squared, and we drop our next term. Now, x squared times what gives you negative 7x cubed? Hopefully you're saying minus 7x. Now we multiply negative 7x times this trinomial again. We end up with negative 7x cubed, and then minus 7x squared, and then minus 14x. Now we subtract. These go away. We end up with negative 2x squared minus a negative 7x. Be careful there. This becomes a positive 5x squared. And then negative 7x minus a negative 14 becomes a plus 7x. And finally, we can drop our 18, so plus 18. And now, x squared times what gives you 5x squared? Hopefully you're saying it's 5. Now we multiply 5 times the trinomial on the outside. So 5 times x squared gives us 5x squared. 5 times x gives us 5x. And 5 times 2 gives us 10. Again, we subtract. 5x squared minus 5x squared is 0. 7x minus 5x is 2x. And 18 minus 10 is 8. This is our remainder. Notice we don't have anything else to drop. So here's how we're going to write our remainders. It's a positive 2x over plus 8. So we're going to say plus 2x plus 8 over the trinomial on the outside. So we'll end up with a final answer of this. All right, hopefully you have a little bit more room than I did there. I'm going to make this a bit smaller so I can do the next question. All right, next question. And at this point, my suggestion is if you feel pretty confident about that, try the next question and then scrub through the video and check your work. So let's go ahead and check, make sure we don't have any missing terms here. Notice we have a cubed term, a squared term, an x to the 1st, and then essentially an x to the 0. So we don't need to add any terms. We can just go ahead and put 50x cubed plus 10x squared minus 35x minus 7 inside our box, and then 5x minus 4 on the outside. Now, 5x times what gives you 50x cubed? Hopefully you're thinking 10x squared. Now we multiply 10x squared times that binomial and get 50x cubed minus 40x squared. We subtract. Those go away. 10x squared minus a negative 40x squared. Be careful there. Is a 50x squared. We'll go ahead and drop our next term of negative 35x. Now, 5x times what gives you 50x squared? Hopefully, again, you're saying plus 10x. Now, 10x times the quantity 5x minus 4 is 50x squared minus 40x. And again, we subtract. 50x squared minus 50x squared is 0. Negative 35x minus a negative 40x, that gives us a 5x. And we drop our minus 7. And finally, 5x times what gives you 5x? It's a plus 1. Now 1 times 5x minus 4 is 5x minus 4, and we subtract. 5x minus 5x is 0. Negative 7 minus a negative, so that's going to give us a negative 3, and that is our remainder. Remember how we do that? We're going to do minus 3 over 5x minus 4. And there's our quotient. All right, so that's polynomial long division. It looks long and messy, but it's so similar to just the numerical long division that you guys have done for years. All right, now we're going to move on to a kind of division that's just faster. It's called synthetic division. The limitation of synthetic division is that it only works when you divide by a linear factor. In other words, you can't have like an x squared right there or an x cubed or anything like that. It has to be just an x. Here's your process. So we're going to write the terms, coefficients, and the root of the denominator. Keep that, I would highlight that. You're going to write the root of the denominator in the top left, not the actual denominator. You do need to fill in the missing terms with zeros if there are some, and then we'll pull down the first number or coefficient, we'll multiply by the root, add the column, and then continue to repeat. That probably didn't make a whole lot of sense, but we will practice it in just a second. Now before we do that, I want you to see the connection between the three types of division that we've done. So we're going to go ahead and do the long division procedure first, and then we'll do the synthetic division, and I'll show you that you get the same answer. So long division, we don't have any missing terms. We go from a squared term to an x to the first to an x to the 0. So let's go ahead and ask ourselves how many times, or what x times what gives you x squared. Hopefully you're saying that it's x. Now I multiply x times the quantity x plus 1 to get x squared plus 1x. Now I subtract. X squared minus x squared is 0. Negative 9x minus 1x is negative 10x. Bring down our next term and get minus 10. Now x times what gives you negative 10x, and it's a negative 10. And then negative 10 times the quantity x plus 1 gives you a negative 10x minus 10. We subtract and we get a 0. So what we find out is that when we divide x squared plus or minus 9x minus 10 by x plus 1, we get x minus 10. Because there's no remainder, that tells us that x plus 1 is a factor of that polynomial. Let's look at that over here on the right. If we wanted to rewrite x squared minus 9x minus 10 over x plus 1, we could factor the top trinomial. We want to find the factors of negative 10 that add to negative 9. So x minus 10, x plus 1, and then we're dividing that by x plus 1. What happens? You can cancel common factors on the numerator and denominator, and you end up with a final quotient of x minus 10. So see the connection between those two. You do different procedures, but you end up with the same exact answer. So now let's do synthetic division. This takes a little bit of practice and a little bit of memorization. So here, I'm going to draw a box, and I'm going to put the root, not the factor that you're dividing by, but the root. So think about what that would be. It would be a negative 1. Now, what we're going to do is we're going to look at the coefficients of that top trinomial. So if I were to fill in the coefficient for the x squared term, it would be a positive 1. So our coefficients are 1, negative 9, and then I guess our negative 10 is a constant. So here we're going to write those down on this row. We'll have a 1, a negative 9, and a negative 10. So here's your process. We're going to pull down the first number, or the first coefficient. Now what we're going to do is we're going to multiply the root by that number, and we're going to put that number here. Now we're going to add negative 9 and negative 1 to get negative 10. The next step is we're going to multiply negative 1 times negative 10, and we're going to put that number here, positive 10. Now we add those two numbers together, and what do we get is a 0. Okay, so what does that tell us? That tells us that we have no remainder. That last number is always going to be your remainder. And then notice here, it looks a little bit wonky because of how I lined those up. We wound up here with a 1 minus 10, but here's what you need to remember. Those numbers are coefficients. I want you to look at this. You're dividing an x squared by an x to the first, so that tells you that your variable that's going to be associated with the 1 is a 1x. And then the next one, you're just going to go down from there, and you're going to get an x minus 10. And notice, exact same answer as the rest of the questions. Okay, I know that's going to take some practice, so just hang in there. Let's do a couple more. So first, notice we are dividing by a linear factor, but we are missing a term. I want you to notice we have an x cubed and x squared, but we're missing an x. So what we need to do is we need to add basically a 0x in here. So when we're doing synthetic division, we'll go ahead and put the coefficient of the first term, the coefficient of the second term, the third one we need to add in as a 0. That is absolutely essential to do, or you're going to get the wrong answer. And then our last term in that last column. On the outside, we're putting the root. So if our factor is x minus 1, then the root is a positive 1. Okay? So here we go. We're going to drop the first number. Now we multiply the root times that first number and pop it up. So 1 times 5 is 5, and then we add -3 and 5 to get 2. Next, we multiply the root times 2 and pop it up. 1 times 2 is 2, and then we add 0 and 2 to get 2 again. And then finally, 1 times 2 here, and we pop it up. So 1 times 2 is 2. -6 plus 2 is -4. This is our remainder. A lot of times I box that. Now, let's just talk about what, these are coefficients. We need to talk about what the variables should be. The key is it's always 1 less than it started with because you're dividing by just an x to the first. So here our final answer should be 5x squared plus 2x plus 2, and then that -4 is your remainder, so you're going to put -4 over the original denominator, and there is your final quotient. All right, and last one, and I again would suggest if you're feeling pretty good about these, to pause the video, try it yourself, and then check your answer. All right, so we need to check and make sure we're not missing any terms. Notice we have a cubed term, a squared term, and a term to the first, and then essentially a term to the 0 power. So we're good there. We don't need to add any like 0 x's. So let's go ahead and fill in our synthetic division box. We're going to put the root on the outside, and we'll fill in the coefficients on the inside. So we have a 2, a 7, a -6, and a -8. Now we're going to drop the first number, and then multiply the root times that first number and pop it up. So we'll have a -8 here, and we'll add that column. 7 plus -8 is -1. Now, root times that next number. -4 times -1 is +4. -6 plus 4 is -2. Next, -4 times -2, we pop that up. That's going to be a +8. We add the two together, and this is a 0. That's our remainder. So that tells us that x plus 4 is a factor of that top 4-term polynomial, and we can write the final quotient as, remember, it's an x cubed divided by just an x to the first, so your first variable is going to always be 1 less than the original largest degree term. So we'll have a 2x squared minus 1x minus 2, and that's your final quotient.